The average American household spends $616 a year on their garden. That number comes from the National Gardening Association's most recent survey. Part of that goes to fertilizer. Part of it goes to soil amendments. Part of it goes to irrigation supplies, drip lines, hose timers, and sprinkler heads. And every single spring, you do it all over again because your soil forgot. It forgot the nitrogen you poured into it in March. It forgot the phosphorus you sprinkled in May. It forgot the potassium you added in July. By October, it's all gone. Leached, washed out, evaporated. According to the United States Department of Agriculture, 40 to 80% of synthetic fertilizer applied to soil is lost to the environment, not absorbed, not used, lost. You are essentially pouring liquid money into a bucket with no bottom. Now picture something different. One trench, one rotting log, the kind sitting in your yard right now doing absolutely nothing, $0. And after that, your soil feeds itself, waters itself. For 20 years, no refills, no trips to the hardware store, no blue bag, no subscription to the dirt economy. This is not a hack. This is not a gardening trend someone invented on the internet last Tuesday. This is a method that humans have used for over 500 years in Eastern Europe and for over 2,000 years in the Amazon basin. And the reason you have never heard of it is not because it doesn't work. It's because a 2-100- and $30-billion industry works very, very hard to make sure you keep buying bags. To understand why burying wood works, you first have to understand why your soil doesn't. Modern gardening has trained us to think of soil as a container. You fill it with nutrients, plants eat the nutrients. The container empties, you refill it. That's the cycle. Buy, pour, grow, deplete, repeat. And that cycle is the foundation of a global fertilizer market worth $230 billion a year. According to Markets and Mark's 2025 report, companies like Bayer, BASF, Syngenta, and Corteva control over 60% of that market. And their business model depends on one thing: your soil must stay hungry. But soil was never supposed to be a container. Soil is supposed to be alive. 1 teaspoon of healthy forest soil contains more microorganisms than there are humans on this planet: bacteria, fungi, protozoa. These organisms break down organic matter, convert nutrients into plant-available forms, build soil structure, and hold moisture. They are the operating system. Without them, soil is just dirt, a dead compacted filter that nutrients pass through like water through sand. And here's the problem. Synthetic fertilizers are destroying that operating system. A 70-year field study published by phys.org in March of 2026 found that long-term use of synthetic fertilizer, particularly high nitrogen combined with low potassium, can cut mycorrhizal fungal colonization in half. Mycorrhizal fungi are the underground network that connects plant roots, transfers nutrients between them, and extends their reach by up to 700%. When you kill that network, every plant in your garden becomes an orphan. It can only eat what you hand-feed it. And the moment you stop feeding it, it starves. A separate study published in the journal PLOS1 in 2020 confirmed that long-term chemical fertilizer application reduces overall soil microbial diversity, degrades soil structure, and increases nutrient leaching. In other words, the more fertilizer you add, the more fertilizer you need. It is a dependency loop. And it is engineered, not by nature, by an industry that profits from the cycle. The Haber-Bosch process, the industrial method used to manufacture synthetic nitrogen. Fertilizer runs at temperatures over 500 degrees Celsius at pressures over 200 atmospheres and consumes roughly 1 to 2% of the entire world's energy supply. It is responsible for approximately 450 million tons of CO2 emissions per year, about 1.3% of all global greenhouse gas output. All of that energy, all of that carbon. So you can pour a bag of blue crystals onto dirt that will forget everything within 14 days. There is another way, and it starts with a dead log dot. The word is HÜGELKULTUR. It's German. It means mound culture. And the concept is almost insultingly simple. You dig a trench, you fill it with rotting wood, logs, branches, stumps, whatever you have. You cover it with layers of organic material, leaves, grass clippings, compost, kitchen scraps. Then you pile soil on top, and you plant. That's it. That is the entire method. No special tools, no special products, no certification, no purchase required. But what happens underneath is extraordinary. As that buried wood decomposes, it becomes a biological sponge. Decomposing wood can absorb and hold between 200 and 500% of its dry weight in water, depending on species and stage of decay. That is not a marketing claim. That is basic wood science documented by the USDA Forest Products Laboratory. The wood absorbs rainfall, it absorbs irrigation, and then it releases that moisture slowly over weeks and months directly into the root zone. Gardeners who use HÜGELKULTUR beds consistently report that their mounds stay moist for weeks without a single drop of added water, even in summer heat. Some report eliminating irrigation entirely after the second or third year, but moisture retention is only the beginning. As wood breaks down, it becomes colonized by fungi, specifically saprophytic and mycorrhizal fungi. These organisms spread through the buried wood like a web, breaking down cellulose and lignin into simpler compounds. They convert locked-up nutrients into plant-available forms. They build what scientists call a mycorrhizal network, an underground highway that physically connects plant roots to each other and to distant nutrient sources. A 2025 paper published in Nature confirmed that mycorrhizal fungi have been constructing these trade networks for over 450 million years. The system is ancient, it is proven, and buried wood is the infrastructure that supports it. Now here is the timeline. And this is important because most people who try HÜGELKULTUR and fail because they expect year one miracles. Year one is the hardest year. Fresh wood, especially large logs, temporarily ties up nitrogen as bacteria and fungi begin the decomposition process. This is called nitrogen immobilization. It's real, and it matters. In year one, you should plant nitrogen-fixing crops, beans, peas, clover, or heavy feeders that you supplement with a thin layer of compost on top. Do not expect record harvests. Your bed is booting up. Year 2 to 3, the wood is now partially decayed. Nitrogen is being released. Fungal networks are established. Moisture retention is increasing. You will notice your plants are greener, your soil is darker, and your watering frequency drops significantly. Year 3 to 5, this is where the magic happens. The wood is now spongy, fungal-rich, and actively cycling nutrients. Productivity increases dramatically. Watering drops to near zero in most climates. Year 5 to 20, the bed is now a self-sustaining ecosystem. The wood continues to decompose, releasing nutrients, holding water, and supporting a thriving microbial community. Some practitioners report that beds built with large hardwood logs remain productive for over 20 years without any additional amendments. One trench, one afternoon of labor, 2 decades of returns for $0. Now, if HÜGELKULTUR is the 500-year-old European version of this idea, then Terra Preta is the 2,000-year-old version. And it's not just older, it's more extreme. In 1966, a Dutch soil scientist named Wim Sombroek was conducting a routine soil survey in the Amazon basin of Brazil when he stumbled onto something that defied everything he knew about tropical soil. In the middle of thousands of square miles of oxisol-thin, nutrient-poor, acidic red clay that most agronomists consider some of the worst farming soil on Earth, he found patches of jet black earth. Deep, rich, alive. Some patches were 2 meters deep, and they were still fertile. Sombroek published his findings in his 1966 book, Amazon Soils. It launched decades of research, and what scientists discovered was staggering. Terra Preta, which translates literally to black earth, was not natural. It was made by human hands. Between approximately 450 BCE and 1500 CE, pre-Columbian indigenous communities in the Amazon deliberately created this soil by adding 3 ingredients to the ground: charred wood, broken pottery, and organic waste, fish bones, food scraps, manure. The results, measured by modern instruments, are almost absurd. A study published in the Proceedings of the Royal Society and cited by PMC found that Terra Preta soils contain approximately 3 times more soil organic matter than surrounding soils, 3 times more nitrogen, 3 times more phosphorus, and 70 times more charcoal-derived carbon. The charcoal, what we now call biochar, acts as a permanent scaffold for microbial life. It does not decompose. Research published by NIBU in December 2025 confirmed that biochar remains stable in soil for over 1,000 years, possibly much longer. And here is the detail that should stop you in your tracks. Terra Preta regenerates itself. The soil grows at a measured rate of approximately 1 centimeter per year. It is, as far as science can determine, a living, self-repairing, self-fertilizing soil system built from charred wood, bones, and scraps by people who had no machines, no chemistry, and no industry, just observation and time. Wim Sombroek spent the rest of his career trying to recreate this soil. He called his project Terra Preta Nova. He died in 2003 before completing it. But his vision lives on in biochar research programs at Cornell University, the University of Bayreuth, and dozens of other institutions. And the core principle of his vision was breathtakingly simple. Stop treating soil as a thing to be fed. Start treating it as a thing to be built. And the building material is wood. This is what you are doing when you bury a log. You are not adding fertilizer, you are building infrastructure. You are laying the foundation for a microbial city that will feed your plants for decades, not because you keep refilling it, but because you gave it the architecture to sustain itself. The Amazon tribes didn't have a 2-100-and-30 billion dollar fertilizer industry telling them their soil was broken. They just had wood, fire, and patience. Here is exactly how to do this. Step by step, no ambiguity. Step 1. Choose your location. Full sun or partial sun. Flat ground or a gentle slope. If you're on a slope, orient your trench perpendicular to the incline so water is captured, not channeled away. Step 2. Dig your trench. 2 feet deep, 3 to 4 feet wide, as long as you want your bed to be. Yes, this is labor. This is the one afternoon of work that replaces 20 years of maintenance. Consider it the best trade you will ever make. Step 3. Lay your wood. This is the foundation. Use the largest, most decayed logs you can find. Hardwoods are ideal. Oak, maple, birch, apple, poplar, cottonwood, alder, and willow all work extremely well. They decompose at a steady rate and support diverse fungal communities. Avoid black walnut. It contains juglone, a natural chemical that inhibits plant growth. Avoid fresh cedar in large quantities. The natural oils slow decomposition and can suppress nearby plants. If all you have is softwood or partially rotted branches, use them. Something is always better than nothing. Step 4. Fill the gaps. Stuff smaller branches, twigs, and wood chips between and around the larger logs. This increases surface area for fungal colonization and eliminates air pockets. Step 5. Add your nitrogen layer. This is critical for year 1. Lay grass clippings, fresh manure, coffee grounds, kitchen scraps, or any green nitrogen-rich material directly on top of the wood. This offsets the nitrogen immobilization that occurs during early decomposition. Without this layer, your first-year crops will struggle. Step 6. Add your carbon layer. Pile on dead leaves, straw, shredded cardboard, or aged compost. This feeds the slower microbial processes and builds long-term soil structure. Step 7. Cap with soil. 6 to 8 inches of garden soil or finished compost on top. This is your planting surface. Step 8. Plant. In year 1, plant nitrogen fixers, beans, peas, clover, lupins. They will feed the bed while the bed boots up. From year 2 onward, plant whatever you want. Tomatoes, squash, peppers, root vegetables, herbs, anything. Step 9. Water once. Soak the entire bed thoroughly after construction. This kickstarts the decomposition process and saturates the wood. After that, watch. Most builders report that by year 2, the bed holds enough moisture from rainfall alone that supplemental watering drops to nearly zero. Total cost, $0 if you use wood from your property, leaves from your yard, and scraps from your kitchen. Total time, 1 afternoon. Total maintenance, almost none. The bed does the work. You harvest the results. So let me ask the obvious question. If this method works, and it does, backed by centuries of practice and confirmed by modern soil science, why don't you know about it? Why isn't it taught in every gardening class? Why isn't it on the back of every bag of soil at your hardware store? Because it breaks the cycle. The global fertilizer industry, worth $230 billion in 2025, is built on repeat purchases. You buy fertilizer in spring, it washes out by fall. You buy again. That is the model. That is the revenue stream. A method that builds permanent, self-sustaining fertility using free materials is not an innovation to this industry. It is a threat. Consider this. The Haber-Bosch process, the backbone of modern synthetic nitrogen production, consumes 1 to 2% of the entire world's energy supply. It burns natural gas. It emits 450 million tons of carbon dioxide every year. An entire industrial infrastructure burning fossil fuels at planetary scale exists to manufacture a product that your soil loses within weeks. And then you buy more. The machine keeps running. Now, consider the alternative. A rotting log, free, available everywhere, burns no gas, emits no carbon, builds soil instead of depleting it, holds water instead of wasting it, feeds plants for decades instead of days. No patent, no factory, no supply chain, no shareholder report. You can see why this doesn't get prime placement on the shelf. This is not a conspiracy theory. Nobody signed a document agreeing to suppress Hugelkultur. But systems protect themselves. Industries promote solutions that generate revenue and ignore solutions that don't. And when the solution is literally a free log buried in dirt, there is no revenue. There is no product. There is no reason for a corporation to tell you it exists. So they don't. 2,000 years ago, people in the Amazon built soil that is still alive today. 500 years ago, farmers in Germany and Eastern Europe buried wood in trenches and grew food without buying anything from anyone. They didn't have chemistry. They didn't have industry. They had observation. They had patience. And they had a relationship with soil that we have completely lost. We've been taught that soil is a problem to be solved with a product. But soil is not a problem. Soil is a partner. And partners don't need to be fed every 14 days with a bag of synthetic crystals. Partners need infrastructure. They need architecture. They need a foundation that lasts. A buried log is that foundation. It is a water tank, a nutrient bank, a fungal highway, and a microbial city, all in one. It costs nothing. It lasts decades. And it works while you sleep. The 200-and-30-billion-dollar fertilizer industry will survive without your $600 a year. But your garden and your soil will be better off without theirs. One trench, one log, one afternoon. That's all it takes to stop renting your soil and start owning it.